These are the solutions to your transformations review sheet to try to help you get ready for your upcoming unit test. As always, be sure that the sound is on and that you're using a grading pen to fix any missed answers. So not just copying in the correct answer, but also the process of how to get there. All right, starting with the first one, we can match up vocab words with each picture. So number 1 is a reflection. Number 2 is a rotation. Number 3 is a dilation. And number 4 is a translation. All right, first I'm going to graph the vertices of the triangle and label them with the letters that they gave. All right, when I plot each of those 3 points, I get the triangle that's shown. Whenever you're doing a dilation, you can multiply each value within your coordinate point by your scale factor to get your next set of ordered pairs. So I will do that. X prime, I'm going to multiply -6 by 1/3. That's the same as dividing by 3. So that would be -2. I'm going to multiply -9 by 1/3, which would be -3. Y prime, -3 times 1/3 is -1. -9 times 1/3 is -3. And then for z prime, I'll multiply each of those by 1/3, which would give -1, -1. All right, I'll take a quick moment to plot those points. -2, -3 is x prime. -1, -3 right there would be y prime. And -1, -1 is z prime. So I get this triangle right there. And then next, I'm going to reflect it over the x-axis. So here's my x-axis. And I'm going to imagine that I'm folding the paper and getting my new coordinates. So this point would become this point. So that's going to be z double prime. X prime is going to become this point right here, so x double prime. And y prime is going to flip right here, so I get y double prime. Okay, now that I have filled in what that looks like, I'm going to list off my ordered pairs. So x double prime is at -2, 3. Y double prime is at -1, 3. And z double prime is at -1, 1. So this set of ordered pairs right here would answer all the transformations we were asked to do. All right, next up, I need to rotate the triangle 90 degrees clockwise around the origin. So just looking at the clockwise rotation, it would do this. When you rotate it around the origin, it would end up right there. Then I'm going to translate it 3 to the right and 2 units up. So I'm going to go 1, 2, 3, and then up 1, 2. So if you did that correctly, new points. So we did 2 transformations. So 2 kind of quotation apostrophe marks. So point A is now at the point 4, 1. B double prime, it's at the point 5, 1. And C double prime is at 4, -2. And then I could take a quick moment to label C double prime, A double prime, B double prime, and those are going to match the ordered pairs that I just listed. All right, when you are determining whether something's an enlargement or a reduction, you can use the size of the scale factor. If the scale factor is larger than 1, you're going to have an enlargement. That means your shape is going to get bigger. If your scale factor is smaller than 1, it's going to be a reduction, which means that your shape gets smaller. And if your scale factor is exactly 1, you're going to get a shape that's congruent. That just means it's the same size. All right, here's a quick review of your 4 quadrants. You have quadrant 1 starting where everything is positive. Then it's going to circle around to quadrant 2, quadrant 3, and quadrant 4. So you could picture a big C on your coordinate grid to remind you what each quadrant is. So if we start with a figure in quadrant 3, and we reflect it over the x-axis, it's going to end up here in quadrant 2. All right, next up, you're going to do several different transformation to get from A to B. That's going to be a 90-degree counterclockwise rotation. To get from E to G, you're going to have a reflection over a vertical line. To get from design A to design H, that would be a dilation. And the shape's getting smaller. It's actually a reduction. So I'm going to say dilation with a scale factor that is less than 1. Okay, for the translation, you have 2 options. You could say A and G represent a translation, or you could say H and C represent a translation. And then for part E, the one that's a reflection and a 90 degrees clockwise rotation would be design F. All right, let's start by filling in the original shape. So now that I've drawn in the original shape, I need to reflect it over the y-axis. So that's going to be reflecting it over this line right here. So I'm going to have A prime, B prime, C prime, and D prime. So that was just a reflection over the y-axis. And then next I'm going to rotate the rectangle 90 degrees counterclockwise. So that means I'm going to go this way around the origin. And the new shape will end up with A double prime right there, B double prime right there, C double prime there, and D double prime right there. So we'll sketch that in, and then we can go ahead and list off your ordered pairs: 0, -2, 0, -5, 2, -5, and 2, -2. All right, next up, you could do this without a piece of graph paper, but if you're still having a hard time visualizing what's happening, it's not a bad idea to just sketch it out. All right, let's start by getting our 3 points plotted. Okay, so your triangle should look like that one. First, we're going to reflect across the x-axis. I'll do that one in green. So here's my x-axis. That means point A is going to come up here, so A prime. Point C will come up here, C prime, and point B, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So B prime would be right there, and I'll take a quick moment to connect those. All right, and after I sketch out that triangle, you can see that it's symmetrical over the x-axis. Okay, now that I've done the x-axis, I need to reflect it across the y-axis. So C double prime would go there. A double prime would go there. And B double prime would go there. So I'll take a quick moment and connect those ones. And then I'm going to go ahead and list off the points. So A double prime would be 5, 2. B double prime would be -3, -6. C double prime is -1, 3. And then we still need to go back and answer how the x and y coordinates are related to the original. And if you notice, this point here, this one here, both of them became positive. Here, both of them became negative. And here, the positive became a negative, and the negative became a positive. So we can just say each value of the ordered pair switched its sign. Okay, or you could just say that you use the opposite, since opposite means that the sign is different. All right, next up, we need to figure out if these two triangles are similar. And to do that, we're going to use a sequence of transformations. If we can get from one to the other using transformations, then the two figures are similar. So I'm going to start by translating this shape right here. I'm going to go up 4, 1, 2, 3, 4, and right 1. Okay, then I'm going to rotate that counterclockwise 90 degrees around point P. So I'll have to imagine that I had this at point P. And then lastly, I'm going to dilate it with a scale factor of 2. So it'll be a little bit tough to show, but when I dilate it, by a scale factor of 2, that's going to match up perfectly on QPR. All right, I'm going to take a quick moment to summarize those transformations that I did. So again, sequence of transformations. First, I translated it up 4, right 1. Then I rotated triangle XYZ clockwise around the point P, which was also the point X. Then I dilated it with a scale factor of 2. And then with all of that, I was able to get it to match up perfectly. So I said the triangles are similar because all the corresponding angles are congruent and all the corresponding side lengths are proportional. That would be enough to satisfy the definition for similar. All right, for this next one, we need two different sequences of transformations to take triangle KID up to the image. So one option is to start by translating this triangle 4 units to the right and then up 1 unit. From there, you can rotate it. We're going to keep that point of rotation right there. And then you can reflect it over the y-axis just like that. So if we were to put that into words, it would look like this. All right, so putting that into words, I think I misspoke before, but we're going to translate it left 4 up 2, which would be x minus 4, y plus 2. Then rotate it 90 degrees counterclockwise. That would be around point K. And then from there, reflect it over the y-axis. That's one possible option. For the second one, I'm going to do a little bit of a more advanced option. I am not expecting that any of you did it this way, and it will kind of look suspicious if this is the only one that you have on your paper. So this is an extension. This is a little bit of a more advanced way to do this. So I can still start with the same first step where we translate that 4 to the left up 2. And then we can actually find a line of symmetry that's going to have a y-intercept right here and a slope that's counted out like this. So if you picture right here, if we make that the line of symmetry, then we could just start with a reflection and not have to do a rotation. So if we do that, again, this is a more advanced option. I'm not expecting that you did it this way. We're going to still translate triangle KID left 4 and up 2. And just like before, that would be x minus 4 to go left 4 and y plus 2 to go up 2. Then, second step, we could write the equation of that line. And I'm going to say reflect triangle KID over the line y equals 2x plus 6. So y-intercept of 6, slope of 2. And again, probably didn't include that as one of your 2, but you need 2 different ones, so you could go back up to the first one and you could find a different order to do those in and still have it count as a different sequence. Okay, moving on. Now we're going to review the angles stuff that we need for the test. So on number 14, I can see that angle A and angle B are alternate interior, which means that they are congruent to each other. So I can set up my equation by just saying that angle A is equal to angle B, or those expressions are equal to each other. So 5x minus 12 equals 2x plus 24. We can subtract 2x from each side. That's one possible starting step. So 3x minus 12 equals 24. Then when you add 12 to each side, 3x equals 36. And so 1x would be equal to 12. Now we need to plug that back in to either of these expressions in place of x right there and figure out what the value of each angle is. So if I do 5 times 12 minus 12, that's 60 minus 12, which is 48. That was the expression for angle A. And angle B should be the same thing, but we can test it and do 2 times 12 plus 24, and 24 plus 24 is also 48. So it's a good way to check to see that we have the correct values. And then when we look at it, it seems reasonable. That's an acute angle, so 48 degrees would make sense for that. Okay, next one. These are not congruent. They are interior, same side interior, which means they're supplementary, and that means they add up to 180. So we can set up 5x plus 34 plus 2x plus 76 altogether equals 180. And then when we start combining like terms, we'll get 7x plus 110 equals 180. Oops. Subtract 110 from both sides. 7x equals 70. So 1x would equal 10. And then we can go back and substitute that in. 5 times 10 is 50. And 50 plus 34 would be 84. So this is 84 degrees. 2 times 10 is 20. And 20 plus 76 is 96. And then we can just do a quick check. 96 plus 84 does in fact equal 180, which is what it was supposed to equal. All right, number 16, you need to use accurate mathematical vocabulary to be able to get the value of x. I'm going to start by labeling the stuff that they gave me. So A, B, C is 35 degrees. And then if I trace B, A, C, that's going to be 105 degrees. So what I'm going to do, there's two options. I could either label this as angle X because those are alternate interior, or I could label this as 35 because those are alternate interior angles. You must have something about alternate interior angles in your description. So I'm going to say the measure of angle BCA is equal to x degrees because it forms alternate interior angles with this angle right here that's already labeled x, so angle CAE. Okay, so that's what allowed me to label that right there. And then next, I can use the fact that all three angles in a triangle add up to 180 degrees. That is the sum of the interior angles of a triangle. So next, all three angles in triangle ABC must add to 180 degrees. So I could set up an equation and say 35 plus 105 plus x equals 180 degrees. We'll go ahead and solve that. So 35 plus 105 is 140. And then that means that x has to be 40 degrees. And then when we look at it, it seems reasonable. That's 40 degrees right there. Okay, second option, I'm not going to write out the second option, but you also have a straight line right here. So that's another way to get this exact same equation I just solved, but using a straight line instead of all the angles in a triangle. Okay, so once again, I would go back and underline alternate interior angles. That's one of the key vocab words you'd need for this problem. Okay, getting close, last couple. For both of these, you're going to use the exterior angle theorem, and that says if you add up the two interior angles that are not next to the exterior angle you're trying to find, it's going to equal that value. So I'm going to put this off to the side for right now. That means that we can do 35 plus 95, and that has to equal the number that we're looking for. So 35 plus 95 equals that value. They didn't put a variable, so I'm just going to keep their question mark. And when you add up those two numbers, you get 130 degrees equals that value that we don't know. Okay, move this over here. I'm going to do the exact same thing for number 18. So I'm going to say 30 plus 4x plus 2 is equal to 8 plus 6x. So that would look like this. 30 plus 4x plus 2 equals 8 plus 6x. All right, if I combine like terms, 30 plus 2 is 32. So 4x plus 32 equals 8 plus 6x. Then I'm going to subtract 4x. That's not the only correct step. It's just the one I'm choosing to do because I like to get variables combined on one side before I deal with the constants. So 32 equals 8 plus 2x. Subtract 8 from each side. And that's going to give 24 equals 2x. And then divide by 2 to get 12 as your value for x. Okay, we found the value for x. Now we're just going to go back and plug it in. So 8 plus 6 times 12 would be the same as 8 plus 72, which is 80 degrees. So 80 degrees represents that angle. 30 is already labeled. And then for blue, I'm going to do 4 times 12 plus 2. So 48 plus 2 is 50 degrees. And again, be sure you have degree symbol. Okay, one last test to make sure that I have this right. 30 plus 50 is 80, and that's what it shows right here. It should equal. All right, thank you for watching, and good luck preparing for your upcoming test.